Oh boy, it's time for the grand finale.
I assume, I hope, probably, right? Yeah, sorting floor. 41. Just one off from having a nice round number, but no, 41. Maybe it'll be easier than the last one, because that one was the final challenge level. You know? Maybe. Hey, check out this new office. We really climbed the corporate ladder together. Thank you. My supervising skills truly are adequate. Your skills are pretty good too. Whatever it is you do over there. So, are you ready? You're such a good supervisor, you literally don't know what I do for my job. Thanks, buddy. How do you sort? Don't ask me. Sometimes I eat the bread before I make my sandwich. Sometimes I put my shoes on before my socks. And I think I'm getting younger. What? I don't think I was ever a kid. Were you? Okay, now I'm paranoid. I gotta check. He thinks he's getting younger. Gotta go back to the beginning. Okay, no, he looks the same. Okay. I'm like, I've been getting older. There's like this nice, spry, new, blue-haired dude. And then much older by now. But he looks the same. I thought I was gonna find that like he had gray hair at the beginning and we've been inverting, like he's been sapping my living essence like Dark Crystal. Okay, so that's over with. So what's our final goal? It's gotta be a big one, right? For each zero terminated string in the inbox, sort the contents of the string, smallest first, biggest last, and put the results in the outbox. Repeat for each string. Oh boy. So we're gonna be doing it's gonna be like sort 3, but the string could be whatever size it wants to be. Oh no! And it also can be, it can be numbers or letters. Because down there, we got 3 numbers first, then we get a 0, and then we have 3 letters, maybe more than 3 letters. Ah. Okay, this is gonna take some time to process. For each zero terminated string in the inbox, sort the contents of the string, smallest first, biggest last, and put the results in the outbox. Repeat for each string. Now it's very simple instructions. Just sort smallest to biggest and outbox that. Okay. So I need to figure out how to generate a string and maintain its length. Huh. This is gonna be interesting. I need to figure out, huh. This is gonna be weird. 'Cause I need to... So before I was doing a thing where I found out... I was basically just doing a tree, because I knew it was only going to be 3 digits. So I think I basically did an outcome tree of what the combinations of things that could happen were. But if we're gonna have variable length strings, now I can't just have an outcome tree of every possibility, because that quickly becomes spaghetti nightmare. So I need to worry about stuff like how I'm gonna handle the string changing in length. I have one working idea in my head right now that's kind of silly, but I'm thinking about it, which is the idea of like, what if I start on like digit 12, that one in the middle of the entire screen? What if I started in the middle and I had 2 stored values, one for the beginning of the string and one for the end of the string, and I basically just expanded backwards or forward as the string grew to give it space to grow, basically. But that doesn't really put my problem away, because I was trying to avoid the problem of having to reorganize the string. So I was like, oh, if I just build, if greater value, if I just put smaller values to the left and bigger values to the right of whatever first one there is, then I could just grow out that sideway, and then I don't have to deal with the issue of like, what if get a value that has to go in the middle of the word. But that only really solves the problem for a moment. The moment I get past the first word, we then have a problem, because I then have to deal with the idea of, man. But then I'd have to deal with the idea, like, if I put something in 12 and then something bigger happens, so I put that in 13, but then something that's bigger than 12 but smaller than 13 happens next, then I'd still have to reorganize them. One thing I'm thinking of, though, is I've been doing stuff lately where I search the entire index, partly due to, like, the factorization and stuff like that. I'm kind of thinking, like, what if I search the entire index for the smallest thing, and then put that first, then search the index for the next smallest thing, and put that first? Like, I could take a value and subtract it from all the other values from it one by one, and try to find the one that never reaches a negative or something. And then that would be a way of sorting it. Like, if I take the 35 and I subtract 61 from it, and I subtract 91 from it, for example, and like, I'm like, oh, that became a negative no matter what. I must already be holding the smallest value. And then I would take that smallest value and I would get rid of that. Like, I'd be like, okay, that one goes in the string as the first smallest value. And then I guess I would have to reorganize. I'd have to reorganize the string. No, I could do something interesting with that. Because the string, the way we terminate strings is with a 0. No, I can't do that, can I? Shit. I was thinking we terminate strings with a 0, so I should put something not 0 in the spot of a removed string, like a removed entry of the string. So I was thinking, okay, cool. What I could do is I could then take that and I could replace it with a negative, like a -1 value. And then I'd be like, okay, if negative, skip this slot, but don't end the string. And you keep going until you're out of entries in the string. But that doesn't work because the game has not assured me that there won't be negative values. In fact, let's just cycle it to see. Okay, we have more numbers and letters. We seem to be consistently doing numbers and letters. No negatives so far. Okay. It might be possible to include negatives in my sequence, I suppose. But I don't know for sure. What do they give me here? They're doing copy from 24, copy to 20. So putting a 0 over there. Then they're going to the inbox. And they're copying the inbox to the target of 20, which is 0. Yeah, that makes sense. And then they're looping that, where they bump 20. Yeah, so the existing... This existing algorithm they gave me to start with is just going to put the string down, and it is a functioning starting algorithm for that purpose. I'm not entirely sure why they gave it to me, because it's basically what I've been doing already up until this point, so maybe they're just saving me some time, I guess, even though this is going to be so time intensive that I don't think that... Not enough stuff in the outbox. Oh yeah, the algorithm ends there. It doesn't have a loop, so it's not going to keep going. Yeah. Let's add a jump all the way back to the beginning and max this out. So, numbers, false, a lot more. Oh boy. Oh boy. Okay. Okay. I see what's going on here. So they start us off with a short string of numbers. Then they give us a string of letters. Then they give us a very long string of numbers. Then they gave us a string of one number. So that seems to be the cases I have to deal with. It does appear if I want to use negatives as a tool, I can, because this program does not expect me to use... The inputs don't seem to include negatives no matter what. We could cycle it a few times if we want to be sure. But yeah, they give me a 3-string number, then they give me words. Then they give me a long string. The first time it was 10 digits. It probably is always 10 digits. Then they give me a 1 digit. So I need to set the program to be able to tell if there is nothing to sort. Because there's nothing to sort if there's only 1 digit, so I would just output that 1 digit and that'd be it. Among other things, so it's testing two things there. One, when it comes to the final one, that's only one digit, they're testing two things. One, is my program set to output the thing if there's nothing to sort without breaking. But also, each string gets longer. There's a 3-digit, a 5-digit, and a 10-digit in the strings. Then there's a 1-digit. So it's testing whether or not you're end capping your string, because if it does the 1-digit number and then it stops, then I need to end cap that string, because I need to be overriding the data that the other ones were writing. Each time it starts over at 0, but if it doesn't end with, but if I don't end it with a 0 to end the string when I'm putting it down, then it'll keep going, and when it goes to test that 1-digit string, it's gonna then go grab all 10 digits, where it'll be just the previous 10 digits, but the first one's overridden by the new one. So if you're not end capping it, then it's still there. It speaks to what I said before about hard drives and how the data can still be there, and it's just a matter of whether or not the program's calling the data or not. All the data from the 10-digit one is still going to be there, and I'm going to override the first digit with the 1 digit they give me, and then override the second digit with a 0 to tell it to stop with there, because otherwise it's going to read the old data that's not part of the current problem. Oh boy. I'm just processing the problem, and we're already like 10 plus minutes into this video, so this is gonna be a long one, I can already tell. I'm a little hesitant to start. The reason why I'm going slow here is I'm trying to formulate my plan, and if my plan is bad, I'm gonna spend half an hour executing an idea that doesn't ultimately work. And so that's part of the reason why I'm sort of spending more time on this. The current thing I'm stuck on is how to remove, like, I think I have a working solution for the idea of how to sort, but I'm figuring out how do I deal with the string I'm sorting. So I'll be sorting the string. Maximum digit size so far is 10, so I could have the string be here, and I could have the sorted string be down here. But like, if I'm very careful and I make sure that I'm definitely dealing with the smallest digits and putting them in the correct order here, I don't have to resort this string. It should be the correct way the first time when I'm transferring it from the top one. But I need a way of dealing with this string getting shorter over time. I'm going to be removing digits from it. There are two ways I could do that. Is I could replace the digit that I've removed with a -1. That's one option. I could make it a -1. And it becomes, and have an if negative thing where I just skip the negative digits. Or I can do a thing where if it becomes negative, I then go to the next cell and move that one over here, and then snake that way through the whole sequence. Oh, you know what might be cleaner? I'll have a stored value that tells me how long the string is, probably. What I could do is I can go to the last digit, copy that one over. I can copy the last digit over to the newly blank digit, and then make the old one a 0 now, and if there's a stored value that says max, like, make that one go down by 1, and that would shrink the string. Since maintaining the order of this top row doesn't actually matter, ultimately. Oh, there's a lot of ways of handling this, and all of them are kind of a nightmare. Cool. Let's just do this one first. So, right. This is just me. This is just me going to the inbox. Let's be consistent. Let's just call it inbox. That's when I write down the inbox. This is my stored 0 value. If I don't keep that there, I'll lose it forever. My one concern is if I do that where I have these 10 digits and those 10 digits, then I only have 4 things I can store. So I've got to be careful how many things I come up with for my system here. The alternative would be to find a way to sort this somehow without using a duplicate string to be the output string. But that would be a nightmare of its own, because then I would have to be rearranging the letters on the fly, which would be a lot of, like, taking something down here, storing it, moving everything around, putting that back where it needs to be or something. And I don't know if that's any better. We'll see. Okay, so at the moment it just copies everything into here forever. And it stops. If it reaches 0, it stops. So we're gonna get rid of this loop I added, because we want the if 0 to be where it actually does stop. And then it's going to start sorting. Begin sort. So it goes to the inbox, it writes our first word. Let's make sure it's absolutely right about that part, since it just takes a second. There we go, yeah. So it's gonna write the word, and that's all we have so far. Now we need to sort that word. Hooray! Let's see. Let's do jump if 0. Inbox copy to 20. Okay. So at that point, that already is a maximum string. What they gave me already becomes the maximum string. 20 is currently pointing at where the 0 is. Technically max plus 1. It's pointing to where the 0 is right now, which is 1 beyond the end of the string, technically. So let's just, I'm just putting that in the name of the label to make us remember that. Because it's gonna go 1, 2, 3, 4, or 0, 1, 2, 3, and this is the, like, this is the string, this is the 0 that's after the string, and that's where max is actually pointing to. But as long as I keep that in mind, we should be able to work with that. If I'm gonna write a duplicate string, I need to have 10 stored as a value. I think I just need to set that up from the beginning, more or less. Do I have to literally bump it up that many times? Kind of, yeah. Alright, so just for our initialization, copy from 0. Copy to what we're gonna call 10. And then I guess we're just gonna start bumping 10. Bump 10. Bump 10. Bump 10. Copy from 10. Add 10. Add 10. Because 3 bumps makes it 3. Then add 3 twice, and now it's 9. Then bump 10. That should at least save on the number of commands a little bit. What happened? Oh boy, what did I do? Oh, copy 210. There we go. Now it's a 10. There we go. I was like, wait a minute. What did I do? What did I do wrong? Alright, so now I have a 10 value stored here. I don't know if that's the best system or not, but 10 would let me refer to this cell as the start of the string we're going to output to. We'll see if that works. I might quickly run out of variables I can work with, in which case I need to have a new system, apparently. Jesus. We'll call you Max. I've recognized a problem. Damn it, I need to double check this, so I need to have a loop here. There we go. I was like, I don't know what I just did. I clicked on the wrong one. I think I have a... Why is it... Oh. Just trying to look at something, damn it. I want to look at the longest digit thing again, because I think I have a significant problem. Yep. Shit's fucked. Okay, my premise does not work. Great. 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 Alright, so the 10-digit number, it covers these 10 digits, then it puts the 0 here. The end string reaches 10, which is a problem, because that means that the next string would have to start here, and its end string would be like here? And then I have nothing to work with. Oh boy. So my plan of writing a second string that I sort correctly is not going to work. I have to sort the string on the fly. Okay. What is a way of handling this that might be very time inefficient? I suppose you could take each value of the string, subtract the next value in the string, and then based on the negativity or not of that, surmise which one of them was bigger, and just check everything against the next value. Because the end result of a successful string would be that every single time you go to the next part of the string, it will always be bigger every single time. So basically, I'd have to create a system where every step of the way, you always successfully get to a bigger number every step. Or if I want to do it backwards, I could sort it in reverse order. Because using if negative as the fail state is a little easier. So I should probably sort them from biggest to smallest and then just output the string backwards, which is fine. That's not hard to do. In fact, it's easy to do. So I could write it backwards. I could do biggest to smallest, where I'd subtract the 0 slot from the 1 slot with the goal of being not negative. And if it's not negative, then I'm like, cool, that means that 0 is bigger than 1. Continue into the next one. Is 1 bigger than 2? And then just keep checking each one against the one next to it. And then if we fail, if 0 is not bigger than 1, oh no, we better make 1 0 and 0 1. So I would write 0 to something down here really far away from all the problems. We don't need 10 anymore. That's an irrelevant number now. So I would write 0 to like 23 to store it. Then I would pick up 1 and I'd store it to 0. Then I'd go down to 23 and I would store that one to 1, basically. And I'm like, okay, now the two are switched. Now, start over. That's the important thing, is it has to start over the entire sequence of sorting, the entire sequence of checking all the letters or numbers. It has to start that over every single time, because otherwise, if it didn't start over every time, then it would just successfully switch the neighbors with each other to make them momentarily true, but it wouldn't work out the entire string being sorted. So if I do that, just check everything against its neighbor, and also every time anything goes wrong, start the whole sequence over with a new string, then eventually the entire thing would eventually become sorted numerically in order, and that would fix the problem. I'm scared that I don't know what that's going to do with letters. I'm a little spooked about what that's going to do with letters. We can subtract letters from each other. So no, that shouldn't matter at all. Yeah, I can't use bump on letters, and I can't subtract numbers and letters from each other. But aside from that, the letters should just work identically with each other. Yeah. I think I may have now landed on a model that will work, and it's probably maybe even smarter than the previous one. In particular, because if I put all my variables down here, then whatever I sort could be as many digits as there are up to that point, basically. I don't really like how they put max over there. And so let's get rid of the 10 digit. That was irrelevant, because that whole plan fell apart when I realized the problem. There we go. I'm gonna call this one old, or X. Boink. 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 I don't know how many variables I'm gonna use, but I'm gonna go right to left. Since we're starting here, left to right, I need to leave as much space as I can, so let's move in this direction. Not necessarily necessary, but I felt like setting it up that way. And now I have, so that's it. I'm God here, except for all the parts where I can't solve problems that other people gave me. I'm pretty powerless there. All right, so the writing thing should just work just fine. So now I just need to work on my sorting thing. Okay, so that's max. So I need to start. I need to do one called start. I mean, no, not start. Start will always be 0. So I'm just gonna call this one digit. God, that's a nightmare. It's just a nightmare. That's almost readable. I hate it. I hate it. So current digit, because I'll have to keep track of where I am while I'm going through the process. Okay, so sort may not be entirely accurate either. Let's call it, probably call it scan. Anyway, copy from 0, copy to max, copy to digit. That has to be 0 at the beginning. Or this whole thing doesn't work. I'll put inbox here. No. No, I should overwrite those as being 0 at the beginning of the process, so that'll be part of the inbox process. Anyway. Let's not call this sort yet. I'll put sort even further down. This is called scan. Because sort is what I'm going to call the part where I rearrange the letters. So let's call this scan, because right now I'm just checking the letters against each other to start things out. I think that's a reasonable way to parse this information. So, copy from bracket digit, which should start at 0. And then subtract I think I'm gonna have to have a digit plus 1, basically. Yeah. There we go. Digit plus 1. It's just the one that's, it's just something that's 1 past the digit. So, copy to, digit plus 1, bump, digit plus 1. There we go. So that'll start out as 1. Yeah. So I was gonna say, how am I gonna interact back and forth between two things? And ultimately, the only way to do that would be to have both of them stored at once. The alternative is to like, at the moment I look at something, put it down, then bump up digit, then subtract from digit to look up this one, and then compare them, and then I'd have to like bump digit up and down every time I wanted to change which one I was interacting with, which would just be a nightmare during the sequence. So just having both stored at the same time makes way more sense. If this was programming, like real programming where I have more freedom, I could literally just say digit plus 1 or digit minus 1 to refer to the cell, one above or below that. But they don't give they don't let us do things like that. I can't refer to something that's next to something. I literally have to have a reference to that exact thing, because this is an incredibly limiting system this game gives you. Like, real programming gives you so much more freedom because it's not so weirdly rudimentary. I think some of the challenge, some of the fun of this game might be for a programmer having to use such bizarrely limited tools to do something that they already know how to do on some level, and stuff like that is kind of in that territory. All right, so we're gonna copy from digit and subtract a digit plus 1. And I'm gonna go with my plan of sorting biggest to smallest because that makes this easier. So let's do if negative, sort. Otherwise, if I do copy from digit and subdigit plus 1 and the end result is not negative, then we're fine. It also doesn't matter if they're equal to each other. If they're equal to each other, then we're also fine, because you don't need to sort things that are equal to each other. So if that's the case, then we will bump digit, and we will bump digit plus 1, and then we will loop again. and just loop right back around to the end. I'm going to have to come up with a system for detecting when we're at the end of the string, though, which is max +1. So I guess what I should do here is I should compare. Let's see. We'll be at the end of the string when we're about to pick up the final digit and try to subtract it against nothing because there's no more letters left. So at this stage of the sequence, I should check to see when digit +1 is equal to max. So what I should do is now that I've bumped them up, I'm currently holding digit +1 rather conveniently. So what I'm going to do is I'm going to subtract max, and then I'm going to do an if 0. And that if 0 will be to I'm going to be setting it up so that if we ever fail, we start over. So if I've successfully reached the end of the string, that means we've won. So now it's outbox time. Like, yeah, if I subtract digit +1 from max, or subtract max from digit, doesn't really matter, and my end result is 0, that means we've successfully reached the end of the string and we've sorted the entire string. So now I'm gonna outbox it. So that's where that goes. That's for later. Great. Whew. This might not be so bad. I'm feeling good about this one. This one actually might end up being a little easier than the last one was, like I was hoping it might be, because of the whole that one being optional part. It just took me a while to process what my goal was going to be, like what my plan was, which is a big part of programming as far as I am aware, or as far as I would assume, but is not the most filmable thing, because I was literally just sitting here talking as nothing happened on the screen. But that's the process, boys and girls. At least that's my process. Trying to set up what to do. So if it, I guess the scan field might be done. Not entirely. So at this point, these digits and stuff are all 0, which is fine. So I can go into this without changing anything, but I need to set resetting the scan. So copy from 0, copy to digit, copy to digit +1, or yeah. And then bump digit +1. Because this is me resetting the scan so that we can then start over each time something goes wrong. And what's going to happen is whenever I finish sorting, because we reached a conflict, sort will then refer back to scan. So let's do that. That'll restart the scan from the beginning of the word now that we've rearranged the two things. And it'll have to set 0, all these to be 0, and that one to be 1, so we can start over again. And then it'll proceed forward to copy from digit, subtract digit +1, and so on. And it'll start sorting again. Okay, so now let's deal with the outcome of what happens when I subtract the first thing. I pick up the first thing and subtract the second thing, and I get a negative number, which means 1 is bigger than 0. So now I need to fix that. So I'm going to copy from 0, which is digits location. Let's call this one hold. You could also call it store, like store value, but I've called it hold so far, so I'm just going to go back to calling it hold. Copy to, not the destination of hold, copy it to hold. That's just an actual bracket. Then we're going to copy from digit +1, copy to digit, copy from hold, copy to digit +1. Let's be clear about this. So we're copying from digits, destination, to hold, copying from digit +1, taking it to digit, then grabbing hold and copying that to herc, digit plus 1. There we go. So my logic's right. Digit goes to hold. Digit 1 plus goes to digit. Hold goes to digit 1. So yeah, that's a simple circular rotation where we do a little thing where we hold it here, move that, and put that there. So those two are swapped now. So we jump back to 0 and start over now. And it'll keep doing that. It'll just keep subtracting them against each other, and if the result is not negative, it'll just keep going down the word until it reaches the end of the word. But if it ever reaches a conflict, it will switch those two values with each other, then start over, and it will keep starting over until the entire word or letters or whatever, or numbers or whatever are in the correct order, and it'll loop that forever. Cool. And it'll keep doing that until it's successfully yeah, every time it does this, it's going to subtract digit plus 1 from max plus 1 to try to tell whether or not they've reached the same value yet. Because max plus 1 is where the 0 is, and that's how I check the 0. If I reach the 0, that means I've successfully sorted the entire word, and now we need to figure out how to outbox the word in the correct order, which is not that big of a deal, I don't think. I'm pretty sure all we have to do is bump down max plus 1 so that it now equals max, like the end of the string instead. And then we're going to outbox max plus 1. Sorry. Copy from max plus 1, outbox that. And then loop that, basically? So, if this was where the 0 was, we're going to bump max plus 1 to point here, which is the last letter of the string, and outbox that. And then it's going to bump it again, and outbox that. Bump it again, yeah. And it's going to keep doing that until it reaches the end of the string. So here's the next problem, is eventually max plus 1 will equal... It will eventually reach 0. So I need to be confirming whether or not I've reached the 0 digit yet. Okay. That's pretty easy. I just need to do copy from max plus 1. So I'm going to pick up max plus 1 to check what it is, only after I've outboxed it, and I'm going to do a jump of 0. Because when it reaches 0, I want to stop. It's very important I put copy from max plus 1 after the outbox step, because 0 is still a cell I want to output. So I want to reach 0, output that, and then confirm I'm at 0. I don't want to stop at 0 before outboxing it, because then the first digit won't be put out, or the last digit won't be put out. So we're gonna get to 0. We're gonna outbox that. Then we're gonna check to see if we're at 0 yet. And then when we've confirmed we're at 0, because max plus 1's now pointing at 0, that's when we stop the program, and that's the end. So the jump of 0, I guess, goes to the beginning of the entire program. You win! Ta-da! Yeah. Because then you go back to getting 0 and making all these digits 0 again, and you start scanning the next word by bringing it in. Or first you put the whole word on the table, then you start scanning it, and it all loops again. Yeah. 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 I've lost my place again, which means I might have won. We've done this whole song and dance again. I don't have notes. I'm not writing anything down. I don't have like a workload or a plan I write down on a sketch paper to tell me like what all the steps are going to be. So I just try to remember in the back of my head all the next steps I have to draw still. And sometimes I remember them all and sometimes I don't. And so when I run out of ones I remember, then I'm like, maybe I'm done. I'm not sure. Let's just fast forward this shit and find out what went wrong. I think I know what went wrong already, actually. I think I might be missing a reset somewhere, but I'm not sure. I guess we'll find out. I might already be done. I don't know. Let's just watch. Have a nice little break. Hang out. I don't like alphabetizing letters. because it goes from being a word to being gibberish, probably. And it's like, oh no, we're the bad guy. It's like we're obfuscating communication. It's saying they're in the right order so far. Yeah, it would have stopped me by now if I think I won. I don't know if I one string proofed it yet. I don't know how it's gonna react if it only has one digit. I didn't actually think about this, but it might have already future-proofed itself. I don't know. The poor little guy has to work so fast. He's running around so much. Look at him go. This gonna take a fucking eternity to sort this one. 10 digits? Ah! Because it has to, that 79 and that 71 have to go to the beginning of the entire string. The two biggest numbers besides 94 are at the end right now. So it has to reach those and slowly move them back. Which right now it's doing all the previous digits still. Oh man. I think I have a robust program though. I hope it works. And I never had to do my negative numbers, did I? Yeah, I never had to do my dumb plan of substituting a slot with a negative number as a blank, which would have broken the moment they gave me negative numbers, which they don't, but they could have. And that makes me feel bad as a programmer, even though this isn't my job. Oh boy, this is gonna take forever, but it should work at least. My biggest worry right now is whether or not the 39 is gonna work out, the one-digit number, or the single input, I should say. It's a two-digit number. 39 is 2 digits, but I mean, like, it's a single input. If that breaks the program, I have to watch this happen again, and it's very slow. It's neat though, it's getting there. It's definitely satisfying to watch your creation work. Okay, we've reached the end of the string at least. We're only sorting that 71's the last thing we're sorting. It's just it has to scan the entire word over and over again as it slowly moves the 71 all the way back there. So he has to do this whole song and dance like 6 times until the 71 reaches the 2 slot. This is cool. Oh yeah, they totally tried to trip me up. They gave me 2 18s. So on top of giving you an 10-digit, a 10 input string, they also gave you a duplicate in that string to make sure that you would get screwed over if duplicates were a problem for you. Don't break, don't break, don't break, don't break, don't break, don't break. I have not checked this fringe scenario and I'm scared. No. No. No, it broke. No. 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 This took so long. All right, let's stop. Yeah, it was sorting 39 in the larger string. So, yeah, the current system does not stop if it has 1 digit. Okay. Yep. This is really well thought out. This is a cool game. In the past, it seemed like the number of things they threw at me were just a number of random bullshit. In fact, I'm not always entirely convinced that the string of inbox is going to be consistently testing whether or not the program will work or not. But then that's why they have the thing where like, this worked for this combo, but it won't work for other combos, asshole. And then they warn you. And then like, here's an example of how it'll break. So they at least know to check everything, a large number of inputs and stuff, so on. But this one explicitly checks all the different types of inputs in the first attempt. It does a 3-step string, it does letters and a longer string. It does a very large string to fuck with you if you use too much space for the calculations on the screen, as opposed to me staying down here. And then it goes to a shorter string. It's both a shorter string and a 1-digit string at the same time to check to see if either of those break your system. So like clearly each step of this is another test. That's cool to see. Okay, so scan. Let's see what causes this to break. I know why it's breaking, but I don't necessarily know which part of this process it's breaking at. I probably should have hit stop, but then I would have had to backstep through like so many stages to find where it broke. Okay, I just sat here for a few minutes eating cookies. That's just been my go-to, apparently. I got like, I forgot what that brand is called. Is it American Farms or something like that? I don't know. The brand of chocolate chip cookies where they sell them in like a white bag and in the top, like a paper bag, and the top is like crimped shut, and you like unfold it to open it and stuff, and it's all kind of exciting because you've got like this boxy bag of cookies as opposed to like the trays that like Oreos or whatever come on and stuff like that. It's like, oh, it's a little bag of cookies. I like this one. I get the type where they're really thin and really small, so instead of coming with the mega cookies that are gonna ruin you, it's like 20 tiny skinny cookies, so that I can like absentmindedly get one or two here and there and not be as punished for my bad habits of eating cookies in the first place. So I think I have a plan already. I was just sort of running over in my head how scan works, and I think I already see an opportunity to deal with the exception of there being one digit. So digit points to the first digit in the string, digit plus 1 points to digit plus 1. So I think I just need to compare digit plus 1 to max plus 1. Yeah. I do that in this loop back here, and that's how I end the string. The problem is that the program basically assumes that I'm gonna be comparing something against something else, and then replace them. And the jump if negative thing happens before I compare digit plus 1, and so on. Yeah. Yeah. Huh. I was going to add something to the program. I was going to add it up here, where we jump back to, but we loop down to here and all that. I wonder if I could just take... because bump digit plus 1 happens here. I wonder if I could just take this part where I compare it to max plus 1 and just move it up here. Like, can I just go sub max plus 1, jump if 0. At this point, I bumped digit plus 1 here because I was prepping it in the first place. So right here, it should, if it's a 1-digit thing, it'll already be equal to max plus 1, and I'm already holding it conveniently. And then we could just do sub jump to if 0. It was originally here at the end of this loop, but it's just going to loop around anyway and come back to here. So bump digit plus 1, sub max plus 1. It loops right back into the perfect situation regardless. And the next step is to copy from digit. So it doesn't matter what I'm holding here, so moving it here doesn't affect anything, and it slots in perfectly. I think that might have been it. I think the solution might have been that elegant, which feels really good. Only one way to find out was just to wait for like 5 minutes for this thing to proceed at max speed, because it still takes forever. Ah! Ah! I heard the cheering from my headphones that I wasn't wearing anymore, so I'm back now. Hooray! Whoa! I got really close. Wow. To one of those goals. I definitely got towards the... I've inverted my tendencies a little bit somehow. I got towards the, like, this is the efficient way to code this, and not the, this is the way to make it run efficiently, which amazingly are conflicting goals. Which I'm not used to thinking about, but I guess that is true, yeah. It takes like twice as long as it apparently should, but it uses very little code. If I just go in there and remove one instruction somewhere, like change one little efficiency, I would get the size challenge on the final level. That's neat. Hey, we beat the game. We beat the game. Clicky click.
Congratulations. You've really become an invaluable instruction follower.
Yes, don't worry, your job is safe. We've replaced you with this electronic box.
It's called a computer. It iterates through a list of simple instructions, called a program.
It has a small amount of memory to store data while processing, like tiles on the floor,
It has inputs.
and outputs.
Its simple instructions can be used together in infinite combinations to compute just about anything you can imagine.
A truly efficient worker that never sleeps.
It's going to change everything.
Please take your things and enjoy whatever it is you people do out there. Congratulations.
What a strange ending. Oh, Carol's alive, you guys. Carol's alive. They made it. Boss man, boss lady. Yeah, there's not a lot of people making this game. Most of the people that worked on this game are the translators, technically, by volume, in that somebody had to translate into every language as clearly as possible. Yeah, because this whole studio is like a tiny handful of people. That ending is odd. On one hand, the most obvious part is the funny parody thing of like the idea of like somebody giving their entire life to their company, working hard forever, so hard, just devoting decades of their life, and the moment that they're not relevant anymore, they get booted from the company because a machine can do their job for them cheaper and faster and so on. So all of their company loyalty and life investment is thrown out the window because fuck off. Because capitalism is all about maximizing profit as opposed to actually doing good by your own employees. So on that level, like that's what they're doing. That's the satire moment a little bit. But there's also like a parody of the satire in that our character was doing a job that was baffling and insane. He wasn't just doing some normal-ish job that happens to be made redundant by automation. He was hilariously doing the exact thing that computers do. Like this is the type of joke you only get by knowing what computers are already and reverse engineering the concept of a computer and programming and making that as literally as possible somebody's human job, and then making that be the thing that's, oh no, isn't that, oh no, what a tragedy. Him being a computer was made redundant by the invention of computers. It's like the elephant in the room the entire game was, this is what computers do. And then at the end of the game, they're like, this is what computers do. Like it's the most bizarre parody of its own point as a result, and it gets really funny and awkward and weird because like the whole game you're thinking about like, why aren't they just using computers for this? And then at the end they're like, we're just gonna use computers for this. But that's all happens. For me it gets weirder for two reasons. One, there's the robot uprising thing that's happening, which is like almost not connected and also kind of connected, because both of those people were clearly voice acted by like Microsoft SAMs type things, like voice synthesizers, whereas the other women before were people. They were humans being voice acted as humans, but those two were voice acted by like text-to-speech. So the implication there is that they are machines themselves. But why are the machines in the process of taking over companies when, like, right now clearly the machines are like overtaking the city via military force outside, and that's confusing? Or maybe the machines already took over and those were freedom fighters fighting against the machines that have already taken over years ago, because I'll remind you, every single thing you click on here is you going forward a year. You go through 41 years of working here apparently, which is reinforced by the fact that your character's hair actually goes white over the course of the campaign. But perhaps almost most puzzling of all is that when your character gets fired, he's smiling. He walks out the front door and he's smiling when he walks away, and he looks cheery, and I'm like, I am so confused about the emotional state of any of the characters in this universe and what they're thinking. Is he just like, wow, my job is safe, a computer's gonna do it for me, isn't that nice? And he's just gonna walk away and be like, isn't that cool? The job I cared about so much is still happening. Like, is he doing this job not for pay, but because he thinks the job is important and needs to be done? And being fired doesn't affect his life, and all that matters is that the job is being done, and since the computer's doing it to it, like, wow, what a utopia. I don't know. I'm just kind of... enough weird things and implications happened really quickly at the end that I'm like, I'm not really sure how to read this. I'm way less certain on how to read what they're going for with some of the stuff than I am about Little Inferno and World of Goo by comparison, especially Little Inferno, which is pretty on the nose and less muddied about its final message. Anyway, now I've played Human Resource Machine. Yeah, after the Let's Try, I was just kind of jonesing to play this game a bit more. I kept thinking about it, and I like the games this developer makes. I'm not a big fan of World of Goo. I think the wobbliness of the bridges and stuff, like, which is the premise, admittedly, just kind of annoys me. So I don't know if I've ever beaten World of Goo. I've played it longer than the Let's Try in the past, years ago. I don't know if I beat it or not, I don't remember. But I'm just not super into it. But I've definitely beat Little Inferno before. So that kind of makes sense as Let's Try, is just to be like, hey, check out these games. But Human Resource Machine I've never played until that Let's Try, and I'm like, I do kind of want to play through it. I like the games this developer makes, and I want to go through that. So I did, and I did it all before a single episode of this aired besides the Let's Try. So as I'm recording this right now, you guys don't even know that this series is going to happen yet, which is weird to say. Upsides and downsides, there might be somebody who's very frustratedly trying to shout at me how to optimize, like, one cool trick to optimize your code, and I'm just gonna ignore them the entire playthrough because I did this in the past before the comment existed. But on the upside, besides the frustrated person, everyone else is probably going to appreciate that the playthrough was like pure. This was all my head and trying to figure shit out, and the warts and all comes from that, is that it's my fucked up solutions with no optimizations from the audience because I beat it before any of them got to say anything about it. So that's neat. I like this game. It's a neato game. Weird to record, just me basically just programming and talking about my programming, but the audience has shown that they're into watching weirder shit in the past, including the Patreon Q&A series where I give somebody an incredibly long and exhaustive answer to a question that they ask while not really paying attention to Diablo and just clicking through it, and those videos are like 90 minutes long or plus, and people keep watching those and being like, these are good. I'm like, okay. So while this is an untested thing here, maybe you guys were into it. I don't know yet. Regardless of whether you were into it or not, I'll probably still play 7 Billion Humans just because I want to play it. And I don't know, maybe the excitement would determine whether or not it's like something I do after the next game, or if I do it like months from now. But I'll probably feel the itch to come back to that specifically at some point. But I'll try to not play multiple things of the same type in a row. Like, I try to alternate between, like, here's a puzzle chamber game that's like kind of Portal-like, and then here is a point-and-click adventure game that kind of try to go around a bit, so that's not of one kind. Oh yeah, we got a new Rusty Lake Cube Escape game coming out. That's probably next, or it was aired in parallel. I don't know. See you guys next time. This has been a thing. Check out the game yourself. If you want to play this game, it still has value to you as an audience member. You can still go to the Steam page and you can go get the game because you can beat me. Because I beat the game and I even beat all the optional challenges, but I didn't get those green lights. I did not get those green lights, and I don't know if I could deal with the sanity of that. But look at all those green lights. You can go back to every single level and get better solutions than me. Because you have to make it so that it takes as few steps as possible, and you have to make sure it has the fewest lines of code as possible. And in many of these cases, those are 2 separate programs for 2 separate goals. So you'd have to do the level 2 more times to get those 2 other goals. Sometimes you can do both, as I showed, but I don't think you can always do both. Anyway guys, thanks for watching like always, and I'll see you next time.